Subject is Programming Logic and Design, or PLD. Objective is to learn about computer systems, simple program logic, steps involved in program development cycle, the pseudocode statements and flowchart symbols using Sentinel value to end program, programming and user environments, evolution of programming models. Understanding computer system. Computer system is combination of all the components required to process and store data using a computer. Hardware, these are the equipments associated with computer. For software, this tells the hardware what to do, and this also involves in computer instructions. Under software, we have programs, instruction written by programmers. Another one is application software, such as word processing, spreadsheets, and payroll and inventory. Another is the system software, such as the operating system like Windows, Windows 7, Windows 10, Windows 11. We also have Linux or Unix. There are three major operations in computer hardware and software. We have the input, data items such as text, numbers, images, and sounds. The processing, calculation, and comparisons performed by the central processing unit or the CPU. And last is the output, resulting information that is sent to a printer, a monitor, or storage device after processing. Examples of programming language are Visual Basic, the C Sharp, C++, and Java, used to write computer instructions. Syntax, rules governing word usage and punctuation. Computer memory, this is the computer's temporary internal storage. The random access memory or RAM. Volatile memory, lost when the power is off. Permanent storage devices. This includes non-volatile memory. Compiler or interpreter translates the source code into a machine language statements called object code. Compiler also checks for syntax errors. Program executes or run. Input will be accepted, some processing will occur, and the results will be output. If the program has syntax error, we cannot execute it. Logical errors. These are errors in program logic produced by incorrect output. So now we have understanding the program development cycle. First is understand the problem, plan the logic, code the problem, use software to translate the program into a machine language, then test the program, put the program into production, and maintain the program. So as you can see, the figure 1-1, this is the program development cycle. Understanding the problem. One of the most difficult aspects of programming, the users or end users. These are the people for whom the program is written. Documentation, these are the supporting paperwork for the program. Planning the logic is the heart of programming process. Now, these are the most common planning tools that we can use. The flowcharts, the pseudocode, the IPO charts or the input processing and output, and the fourth one is the TOE charts, the task, objectives, and events. Desk checking, walking through a program's logic on paper before you actually write a program. Coding the program. Hundreds of programming language are available. Choose based on the features and similar in their basic capabilities. Translator program, compiler or interpreter. Changes the program's English like high-level programming language into the low-level machine language. Syntax error. This is the misuse of language grammar rule. Might need to recompile the code several times and programmer corrects listed syntax error. In Figure 1-2, creating an executable program. We can see here the steps in making a program. First is to write and correct the program code, then compile the program. If the program has an error, list of syntax error message would appear here or uh, will be shown here. But if the program doesn't have syntax error, it will now proceed to the executable program. If the program is good, then it will create the program output. Testing the program, logical errors, these are the result when there is an error in the statement. Test, execute program with some sample data to see if the results are logically correct. And we also have putting program into production. Um, Conversion, this is the entire set of action an organization must take to switch over to using new program or new set of program. Maintaining the program. Making changes after program is put into production. Using pseudocode statements and flowchart symbols. What is pseudocode? Pseudocode is an English-like representation of logical steps it takes to solve a problem. While flowchart, this is defined as the pictorial representation of the logical step it takes to solve a problem. So, writing a pseudocode. This is an example to write a pseudocode. representing of the number doubling problem. We have here the start, the input, the condition, the output, which is the answer, then the stop. Programmers preface their pseudocode with beginning statement like start, and it ends with terminating statement, the stop. Drawing flowcharts. Create a flowchart. Draw geometrical shapes that contains the individual statements. Flowchart should be connected with respective shapes and arrows. So if input symbol, it indicates the input operation. Here we will use parallelogram shape to indicate our input operation. In the past example, we know that input in the pseudocode is input my number. Now, the processing symbol, this contains processing statements such as arithmetic, and the shape with respect to processing symbol is rectangle. As we notice, this statement is in a form of arithmetic. That's why we put it in the processing symbol, which is rectangle. Now, for output symbol, it represents output statements. The shape to be used for output statements is also parallelogram. We can see here that the output, my answer, is inside the parallelogram shape. Flow lines, these are the arrows that connect the flowchart steps. Terminal symbols. We should take note that every time we start a flowchart, we need to have a start symbol in shape like racetrack, or also called lozenges. Then every time we end a statement, we should always have terminal symbol of stop. As you can see here in the drawing of flowcharts, the pseudocode is presented in the right side, start, my number, set my answer, then the output my answer, then stop. If we can convert this into flowchart, the look would be like this. We have here terminal symbol of start at the first part, then at the last part we have the terminal symbol for stop. Then for input, we have here parallelogram of input, and rectangle for the process, which is arithmetic process, the set my number. Then after the process, we should arrive at the output in parallelogram shape, also my answer. But here we have a repeating instructions. The figure 1-6 only works for one number. it is not feasible to run a program over and over 10,000 times. So um, we need to create a loop or the repetition of series of steps instead of repeating the figure 1-6 10,000 times, which is also not allowed. Then here, avoid an infinite loop or repeating flow of logic that never ends. We need to avoid creating infinite loop in our flow chart. Let's look here at the example of repeating instructions. In this flow chart, we can see that there is something wrong in figure 1-8 flowchart because it has infinite number doubling program. Don't do this because this logic saves steps, but it has a fatal flaw because it never ends. Another is this one, using a sentinel value to end a program. Now we have an additional diamond symbol shape for decision symbol, and this is also for testing a value. Dummy value, data entry value that the user will never need, and we have here sentinel value under the dummy value. There is also file called end of file, which serves as marker at the end of file that automatically acts as sentinel. We have here figure 1-9 flowchart of number doubling program with sentinel value of 0. As we can see, there is terminal for start and terminal for stop. But don't do it because this logic is not structured. You will learn this in our chapter 3 or lecture 3 part. While the figure 1-10 flowchart uses EOF or end of file in decision in the diamond shape. But we also should not do this because this logic is also not structured. Understanding programming and user environments. For planning, we have flowchart and pseudocode. For coding, we have text editors. In terms of executing, the input from keyboard, mouse, and microphone. While for outputting, the text, images, and sounds. In figure 1-12 is an example of a C# number doubling program in Visual Studio. Now, let's go here in understanding user environments. For command line, location of the computer screen where you type text entries to communicate with computer's operating system. We also have the graphical user interface or the GUI, which allows user to interact with program in graphical environment. Figure 1-13, executing number doubling program in command line environment. For figure 1-14 is the executing number doubling program in the GUI environment. This is in terms of GUI. Newer programming languages are easier to use and much more like natural language. Now, major models of paradigm used by programmer are the following. First is procedural programming. This focuses on procedures that programmers create. Another is the object-oriented programming or the OOP, focuses on object or the things and describes their features or attributes and how they behave. For the last part, summary, hardware and software accomplish input, processing, and the output. The IPO. Logic must be developed correctly. For logical errors, take note that logical errors are much more difficult to locate than the syntax error. Using of flowcharts, pseudocodes, IPO charts, and even the TOE charts is very efficient to plan a logic. Avoid infinite loops by testing for centennial value. Last is to use text editor or IDE to enter your program statements.